Alright, navigation. So, how do we do this? It's pretty straightforward, actually. What I'm going to do first is I'm going to add a point. So I'm going to go here to my TSD. I'm going to go point, add, we'll make it a control measure, and I'm going to make this a, let's see, I'll make it a ground light, which is going to look like an asterisk, and then I'm going to call this my nav point. So for the free text, 3 characters only, that's all it takes. Enter, cool, alright, click on the map, enter again, bam, I now have a control measure added that's going to be control measure 51 since it's the first control measure in the database, the only control measure in the database. And what I want to do is I want to make that my direct. So I'm going to go point, correction, I'm going to go route, direct, and I'm going to put my cursor over the point. I'm going to cursor select the point, and that made it my active fly to. Oh. Well, that's surprising. I guess I do have a couple of additional waypoints in there, or control measures in there. Anyway, control measure 55. It is 7.9 kilometers away from me, and it is to my left. I know that because, well, I can look over there to my left and see the point, but more importantly, I'm looking up at my heading tape. The heading tape with the command heading chevron, it's this open chevron right here, is telling me that I need to turn to the left. So basically, now that I've put my direct in, I'm going to navigate to that point. So I'm going to kill the holds, I'm going to bank the aircraft over, maintain the helicopter in aerodynamic trim the best as I can. And what I'm looking to do is I'm going to put the flight path vector over the top of my navigation fly to queue, also known as the home plate symbol. And so right about there. Trim, and I'll bring the holds on now. Alright, so I need a little bit more right pedal for trim. There we go. Alright, so got the fly to queue, or the flight path vector of the navigation fly to queue. Now let's notice a couple things here. Number one, our command heading chevron is between the velocity vector, or correction, the velocity vector and the lubber line, which is exactly where it should be. This is one way that I can establish and maintain a ground track. The other way that I can establish and maintain that ground track is placing the flight path vector over the top of my navigation fly to queue. Depending on the altitude of this navigation fly to queue, it could be over, under, in the middle of, whatever the case may be. It just depends on how it's set up in the mission planning software. We're 3.6 Ks, our ground speed is 109, so we got no winds, so that's cool. Yep, winds are calm. And notice that we do have this offset between the nose of the aircraft, the head tracker, and the flight path vector. This is totally normal. The Apache, when it's flying, flies with about a 6-degree crab angle. This is actually a little bit much, you know, work in progress, whatever the case may be. But should be about right here for the given airspeed. But this is a normal condition. In a no-win situation, this is what you're looking for. It's totally normal. Now, the other cool thing is, and why I kind of referenced the command heading chevron up here, being between the velocity vector and the lubber line, is because I want to illustrate that I can use this to fly any ground track that I want. So if I want to ground track 090, I need to put 090 between the lubber line and the velocity vector. So I'm going to kill the holds, and I'm going to turn to the right. Maintain the aircraft in aerodynamic trim, and what I'm going to do is I'm going to put the 090 tick mark between the velocity vector and the lubber line. And a little bit of pedal for trim, a little bit more left pedal. There we go. And I need to trim it out. Bring the holds on. And there we go. All right, cool. So there we go. Now, so long as I'm in track up, you can also see, if I bring my HSI on, that I got a grid line. This little grid line is actually going right through 090, which is also another way that I can tell that I am ground tracking on a 090. I'm flying 084 to ground track 090. This difference exists because I have a 180-degree heading tape and a 360-degree velocity vector radial. And so basically this is, if you take 1/2 the distance between the two, that's how you can fly your ground track. It's just how it works. Let's see, what else can we talk about with that? Oh, yeah, well, while we're here, I'll also talk about trim. Aerodynamic trim is the most efficient way for the helicopter to fly. It's going to minimize drag on the airframe. It's going to be the happiest there. We're going to use this whenever we are transiting over long distances or up at high altitude and all that kind of fun stuff, right? Because I'm not really worried about obstacles so much. Now, I'm going to kill the holds, and I'm going to do a little decel and come down closer to the trees. Now, as I start getting closer to the trees, I'm going to start stepping on the velocity vector. And what I want is for that velocity vector to be straight up and down the 12 o'clock probe of the line of sight. I want it touching the lower line the best I can. This is what we call nose to tail trim. And what this is going to do is this is going to ensure that the tail occupies the exact same point in space that the nose did, which was just previously cleared as we flew through it. And this is going to prevent the tail from being swung out into obstacles and all that kind of fun stuff as we continue to come down in altitude. Oh, and I should point out that this is not the most efficient way for the helicopter to fly, not even a little bit. It will require a little bit of cross-controlling, meaning I'm going to have to take and, maybe bank the helicopter to the left or right, depending on winds and other situations, stuff like that, while I am also maintaining that velocity vector up and down that 12 o'clock probe of the line of sight. And I just maintain the aircraft in this position throughout the entirety of my time down here close to the obstacles. Trim. All right, if I want to turn, what I'm going to do is I'm going to start turning the aircraft here, banking the helicopter. The velocity vector is going to go a little bit to the right. I need to apply a little bit of right pedal and left cyclic. Now I need a little bit of right pedal and left cyclic. You're always going to be applying opposite inputs to maintain that velocity vector straight up and down that 12 o'clock probe. Like I said, this right here is really only applicable when I am down low in the trees and I don't want to hit things. It saves the tail rotor, and tail rotors appreciate it. Whoop, wobbling the pedals just a little bit. Okay. And that is pretty much all I want to talk about here. So that's a little bit of navigation and a little bit of chat about trim.